so in this video we're going to talk about basic switch functions, or as I put in the outline, switches. How do they work? First, a bit of review, like I tend to do at the beginning of these deeper concept videos. A switch is a layer 2 or higher device that connects multiple devices similar to a hub. For the purposes of our discussion, we're only going to talk about layer 2 functionality in a switch. Now, the primary functions of a layer 2 switch is to maintain a MAC table, MAC being the Ethernet address or the media access control address, the layer 2 address. It uses this MAC table to send frames only to the end stations that they are destined for. And you might ask, well, how does a switch know? How does it know what workstation a particular frame is destined for? It populates this MAC table by watching the incoming Ethernet frames and remembering what port those frames are seen on. And I've got a little diagram here on the next slide, and it'll make a little more sense if you're more visual like I am. In short, the switch examines the frames that comes through it and forwards them to the destination device. And I've got forwards in bold here, because that's one of those technical terms that we keep going on about. A switch is said to be in the forwarding state when it is actually processing frames and sending them on to their destination. And as we talk about switches more in depth, you'll hear me use the term forwards this frame, and this is exactly what I'm talking about. Now, there are three basic forwarding modes in any kind of network switch. We have the store and forward, the cut through, and the fragment-free forwarding modes. And we'll talk about the differences of those here on the next slide. Now, certain switches can change modes on the fly if needed. For example, let's say a switch starts out in store and forward mode, but after a little while it determines, well, I've not seen any errors come through on any of these ports. I'm just going to switch it to cut-through forwarding and speed up the network traffic that's going through the switch. So let's talk about these three forwarding modes. The first is the store and forward forwarding mode. In the store and forward mode, the entire frame is received in the switch, and the FCS, or the frame checksum, which you'll recall when we looked at the diagram of the layer 2 frame, the FCS is validated to ensure it's a good frame before forwarding it along to the destination device. Now, store and forward is the default operation mode for most Ethernet switches out there. When you get into some of the really high-end, low-latency switches, they may not use store and forward unless you specifically tell it. But most switches, if you were to go buy a switch off the shelf at Best Buy and hook it up into your network, it would be using store and forward mode. Store and forward introduces more latency or delay into the traffic path simply because it does have to receive the entire frame, look at the frame, run a checksum on it, and say, yes, this frame is good, it's destined for this MAC address, and I'm going to forward it out port 7, or whatever port it is. However, the trade-off for introducing this latency is that the switch is highly reliable, as in it won't forward out frames that it knows are bad because it checked the checksum and said, well, this frame is not any good, and so it just rejects the frame right there. Store and forward can also forward between different speed interfaces. Let's say your input interface is 100 megabit and the output interface is a 1 gigabit, or the opposite way around. Because it's looking at every frame that comes through, it doesn't necessarily have to match the speed on both sides. The next switch mode we'll talk about is the cut-through forwarding. With cut-through forwarding, the switch forwards the frame as soon as the destination MAC address is seen, which is about 16 to 20 bytes into the frame. Now, obviously, because the switch is not checking the entire frame, it does not introduce nearly as much latency, and so you will get quicker communications by a few milliseconds using cut-through forwarding versus store and forward forwarding. However, using cut-through forwarding, you have the ability to introduce bad frames into the network. Since the switch isn't looking at the checksum, it just says, well, you're supposed to go out port 7, I'm sending you out port 7, and it's up to the network card on the other end of the link to determine, hey, this is a bad frame because my checksum doesn't match, and tell the sending station, hey, you need to resend this particular frame. So the last forwarding mode we're going to talk about is fragment-free. It forwards the frame after the first 64 bytes are received, which basically puts it as a mix between store and forward and cut-through switching. Now, fragment-free forwarding reduces collisions because the switch can tell after the first 64 bytes whether or not this is actually part of a collision, but it may still introduce bad frames because fragment-free switching still does not examine the FCS in the Ethernet frame. And I'll be perfectly honest, I've been dealing with network switches for over 10 years now. I can't ever recall seeing a switch that's using fragment-free forwarding that either all use store and forward or cut through, depending on configuration and business and technological needs and so on and so forth. Most of them use store and forward just because it's nice to have those error counters in the switch so that you can very easily look in your switch's command line interface, which we'll do here in the next section, and be able to tell, we're getting a boatload of errors on port 27. There must be a bad cable or a bad network card or a bad patch panel. There's something about port 27 that's not right. And you get your cable tester out and you go find out what the problem is. 9 times out of 10, it's a bad cable. But this isn't troubleshooting. This is CCENT, so we won't go too far afield with that. So let's look at a very basic network and look at how a switch makes its forwarding decisions. So let's say we've got 4 computers like so. They are all connected to an Ethernet switch. And there's the MAC addresses. Obviously, these are all fake MAC addresses, but they work for our demonstration here. And these particular workstations are connected to ports Fast Ethernet 01, 02, 03, and 04 on this particular switch. And you can see I'm not very imaginative. The one with all the 1s in the MAC address is on port 1. The one with all the 2s in the MAC address is on port 2. I'm not very creative in some ways, I guess. So as these workstations send packets across the network, the switch learns, all the packets from the 4 MAC address seem to be coming in on port Fast Ethernet 04, so I'm going to put that in my MAC table. And I'm going to remember that all the ones with the 4s are on port 04. All the ones with the 3s are on 03, as an example. So let's walk through the switching decision on a particular Ethernet frame. So workstation 1 over here sends out an Ethernet frame, and it says that my destination address is 000000444444. So this frame makes it to the switch. The switch looks at the destination address and says, well, I've got this destination address somewhere on my MAC table. What port was that MAC address on? And so the switch forwards that frame out to just this workstation on port Fast Ethernet 04. It doesn't send it out to any of the others unless the switch doesn't know what this MAC address is, at which point it will flood it out to all of the ports and wait for one of these guys to say, oh yeah, I've got that MAC address. I'm over here. You send it my way. This workstation over here then replies back, its destination address is all 1s, and the same process works in reverse. I'm going back this way, hey, you're on port Fast Ethernet 01, and it sends it out to this workstation here. What's really impressive in all this is that, this sounds like something we could do as human beings. The switch makes all of these decisions in microseconds. It just processes hundreds or thousands of packets a second through these switches. And it's still kind of amazing, even though I deal with this stuff every day, that these switches are just so fast, at least in modern times here. And the technology has just increased by leaps and bounds just over the last few years. And that concludes our discussion of basic switch functions.